on complex numbers, right? The real number system, that is the number system, as we know today, is a result of gradually development in uh, as natural numbers. That is 1, 2, 3, 4. Okay, and these are positive integers. Okay, we use for counting. Okay, and if a and b are the natural numbers, the sum of a plus b and the product will be a into b. Okay, or also a natural number. And there are negative integers and zeros, right, which are and zeros. Okay, so which are denoted by that is -1, -2, -3, okay, and 0. Permit solutions of equations such as that is x plus b is equal to a, where a and b are the natural numbers. So this leads to the operation of subtraction or inverse of addition. Okay, or we write this as x is equal to a minus b. Also, integers are closed under the operation of addition, multiplication, and subtraction. Also, we have rational numbers such as 3 by 4 minus 8 by 3. Okay, these permit solutions of equation as bx is equal to a. For all integers, that is a and b, where b is not equal to 0. Now this leads to the operation of division or inverse of multiplication, and we write this as x is equal to a divided by b. Okay, where the quotient of a and b. Okay, where a is in the numerator and b is in the denominator. We have irrational numbers, okay, such as √2 and pi, that cannot be expressed in the form of a by b, and where a and b are the integers and b is not equal to 0. Okay. The complex number system, that is there is no real number x that satisfies the polynomial equation, which is x square plus 1. Okay, x square plus 1 is equal to 0. So this permits this permits solution of this and the similar equations to a set of complex numbers. Okay, so we can consider a complex number as having the form A plus bi, where A and B are real numbers, and I is I, which is called an imaginary unit, has the property that is I square, which is equal to minus 1, I square, which is minus 1. Now, if Z is A plus bi, okay, then A is the real part of Z, and B is the imaginary part of Z, and are denoted by uh, RE curly braces Z, and I am curly braces Z. Okay, uh, the symbol Z, which can stand for a complex number or a complex variable. Complex variable. Okay.
B D I.
Yeah. B minus D I. Yeah. So that's it. So the real part and the imaginary part. Very easy. Okay. So multiplication and division, right? Okay. So we'll look into absolute value. So absolute value or modulus, okay, of a complex number a plus bi, okay, is defined as mod a plus bi, which is square root of a square plus b square. So this is the example for finding the modulus of a complex number. Okay. Now, uh, if z1, z2, z3, zn are complex numbers, okay, the following properties hold. Okay, these are very important properties which hold. That is z1, z2, which is equal to mod of z1 mod of z2. Okay, or we can, if we have n m number of those, so that will be multiplied again, that will be z1 z2 mod of particular one. Okay, and also we have another property which is z1 by z2, which is equal to mod of the same, right? So Z1 by Z2. Okay, individually mod. We can put this also. So if Z2 is not equal to 0, okay, and we have one more property, that is Z1 plus Z2, which is less than or equal to mod of Z1 plus mod of Z2, okay, or with respect to m terms, so that will be Z1, Z2, Z3 and Zm, okay, less than or equal to Z1, Z2, right, plus Cm, okay, and also we have another property, which is Z1 mod of Z1 plus or minus Z2, which is greater than or equal to mod of Z1 minus mod of Z2. Okay, so please remember these properties. So we have one more Eyeless formula. By assuming that the infinite expansion e to the power of x, which is 1 plus x plus x square by 2 factorial plus x cube by 3 factorial and so on, of the elementary calculus, when x is equal to I theta. So this is e to the power of I theta. Okay, so you get cos theta plus I sin theta. Okay, which is called the Euler's formula. Okay, it is more convenient, however, if we uh, uh, take as e to the power of I theta cos theta plus I sin theta. In a general, we define as e to the power of z, which is e to the power of x plus iy. Okay, e to the power of x plus if you multiply this, so cos y plus I sin y. Okay, so in special case, if y is equal to 0, then it is reduces to e to the power of x. Okay, so please remember this. And also for the uh, de Moivre's theorem, it reduces to e to the power of I theta to the power of n, which is equal to e to the power of I n theta. Okay, I square, I cube, I power 4, I power 5, and I power 6. Okay, okay, fine then. Yeah. Okay, we shall find this. So z as 2 minus 3i. Okay, z bar is the conjugate of it, so 2 plus 3i. Okay, and mod of z square is 2 square plus minus 3 whole square, which is equal to 13. Okay, and therefore the multiplicative inverse of is given by z inverse, which is z bar by mod c square. Okay, or which is 2 plus 3i by 13. Okay, so when you separate with real and imaginary, so that will be 2 by 13 plus 3 by 13i. Okay, so this will be the multiplicative inverse. So that would be taking this as the given one. Now the denominator one, the conjugate, multiply and divide by 1 plus root 2i. Okay, 1 plus root 2i. Right. So you get this as 5 plus 5 root 2i plus root 2i minus 2 divided by 1 minus root 2i whole square. Okay, so which further simplification you would get as 1 plus 2 root 2i. Okay,
Yes, sir.
yeah. Also, let us find I to the power of minus 35. Okay, this is 1 by I to the power of 35. Okay, and we know that I square and to the power of the 17. So because 17 into 2 is 34, right? And I is still left, so that will be 35, right? So I square is minus 1. So to the power of 17 will be minus. So you'll get in the denominator as minus I. Again, multiply and I, right? So which will lead to I. So let us try to find the solution for this. Okay, so first we'll look at uh, the inner brackets. Okay, so we'll try to simplify first. So we get that as 4, okay, minus I, okay, and then we'll multiply this. So this becomes minus 4, okay, plus I and plus 8I and minus 2I square. Okay, so again I square we know that as minus 1. So after simplifying you get minus 2 plus 9I. Okay, let us find the solution for this. Okay, so when we multiply this we get this as my minus 5 into 3 by 5, okay, into I into I. Okay, so which will get as minus 3I square, which is equal to 3. Find the solution for this. So we'll write down the 5 plus 5I by 3 minus 4I. Okay, now uh, let us take the conjugate of 3 minus 4I, which is 3 plus 4I by 3 plus 4I, okay, and 20 by 4 plus 3I, okay, and conjugate of this will be 4 minus 3I, okay, by 4 minus 3I. Okay, so uh, let us multiply. So this is 15 plus 20I and 15I plus 20I square, right? And in the denominator you will have this is a minus b and a plus b, so this is 9 minus 16I square, okay, plus this will be 80 minus 60I by this is 16 minus 9I square. Okay. So and further if you simplify, this will have minus 5 plus 35i divided by this will be 25, and this is 80 minus 60i. We'll keep it like that because we'll simplify this later. So since the denominator is same, we can put that together, and then finally get 3 minus I. Okay, after solving it. So let us find the solution for this. Okay, so I'll consider 1 by 3. Okay, plus 7 3i plus 4 plus I by 3. Okay, I remove the brackets. Okay, and I'll take minus inside, so this will be plus 4 by 3 minus I. Okay, so on further we'll take these fractions. Okay, so that is 1 by 3 plus 4 plus 4 by 3, and I terms together I, and that will be 7 by 3 and plus 1 by 3 and minus 1. Okay, so for the simplifying, you get 17 by 3 plus I into 5 by 3. That's it. Okay, let us find the modulus and the argument of z. Okay, so we have been given this, right? So let us consider that r cos theta as minus 1. Okay, and r sin theta as minus root 3. Okay, now let us square and add uh, these two. So you will get on the left hand side r square cos square theta, and adding this also, that is r square sin square theta, squaring and adding. Okay, likewise we'll square this also on the right hand side, and we'll add this also, minus root 3 whole square. Okay, we are done squaring and adding. Okay, so we get this as r square, so this is cos square theta plus sin square theta. Okay, so this will be 1 plus 3, which is 4. Okay, so cos square theta plus sin square theta, which is 1. So this is r square is equal to 4, or r is equal to root 4, which is 2. Okay, we'll consider r greater than 0. Okay, conventionally we'll consider this. So modulus is 2. Okay, now since both sin theta and cos theta negative, and sin theta and cos theta are negative in the third quadrant, so the argument will be minus of pi minus pi by 3. Okay, which is equal to minus 2 pi by 3. Okay, okay, so let us find the solution. Z as minus root 3 plus I. So let r cos theta, which is minus root 3, and r sin theta as 1. Okay, and squaring and adding both sides, so you get r square cos square theta plus r square sin square theta. Okay, so here also we add and square it. Okay, say take r square common, cos square theta plus sin square theta. Okay, so when you add this, you'll get 4, right? And further cos square theta plus sin square theta, which is 1. So r square you get as 4, or r is equal to 2. So again here we conventionally we take as r greater than 0. Okay, so modulus is 2. Okay, so now r is 2, so 2 cos theta, right, which is equal to minus root 3, and 2 sin theta is 1. Okay, or cos theta, which is uh, minus root 3 by 2, and sin theta, which is 1 by 2. Okay. Therefore theta will be pi minus pi by 6. Okay, so which is 5 pi by 6. Okay, okay. So r is 2, that modulus is 2, and the argument is 5 pi by 6. Okay. Okay, let us find the solution for this. Fine. So this is 1 minus I. Okay, again let us take that is r cos theta is 1, and r sin theta, which is minus 1, right?
Minus 1.
So squaring and adding both sides, r square, so we know this cos square theta plus sin square theta, right? So which is equal to 1 square plus 1 square, right? Again, this is r square, we get this as 2, or r is equal to root 2. Okay, we got this. So we take this r as greater than 0. So root 2 cos theta, which is equal to 1. Okay, so cos theta will be 1 by root 2. Okay, and sin theta uh, is also, you'll get this as minus 1 by root 2. Okay,
Yes, sir.
so and theta lies in the fourth quadrant, so that is theta, you'll get that as minus pi by 4. Okay, fine. Now, so here let me, so 1 minus I, right, which is equal to r cos theta plus I sin theta, right? So which is equal to, so we got r as root 2. Okay, there is r here. Okay, don't forget that. So root 2 cos, now theta, which we found as minus pi by 4, uh, because it lies in the fourth quadrant. So this is minus pi by 4. Okay, and plus I root 2 sine minus pi by 4. Okay, okay, further we can write this as root 2 as common. Okay,
Yes, sir.
so this will be cos of minus pi by 4. Okay, plus I sine minus pi by 4. So this will be the required polar form. So let us solve this. Okay, so again z is equal to 2 plus 2 root 3i. So r cos theta, which is 2, right?
Yes, sir.
R sin theta, which is 2 root 3. Okay, now squaring and adding, so you get r square cos square theta plus sin square theta, which is 2 square plus 2 root 3 whole square. Okay, so further this will be r square and cos square theta plus sin square theta, which is 1. So this will be 4 plus this is 4 into 3, which is 12, right? So this will be 16, right? So you get r as 4, again considering r greater than 0. Okay, okay, and theta, that is r, which is 4 cos theta, which is 2. Okay, and 4 sin theta, which is 2 root 3, or uh, this will get as cos theta as 1 by 2 and sin theta as root 3 by 2. Okay, okay, so here
Yes, sir.
if you consider this as theta will be 60, which is pi by 3. Okay, okay, now let us take 2 plus 2 root 3i. Okay, so which is r which is 4, right? Okay, let us put that cos pi by 3 plus I into 4 sin pi by 3, right? So we'll take 4 common. Okay, so this will be cos pi by 3 plus I sin pi by 3. Okay, also we can write this as 4 into e to the power of pi I by 3. Okay, so let us express the given complex in the form of a plus ib. Okay, let us try to solve this. Okay, let us multiply it so throughout, and we'll get that as 21 plus 21i, okay, plus
Yes,
7i, right?
yes, sir.
Plus this is 7i square, right? So we know what is I square. I square is
Yes, sir.
minus 1. Let us substitute it. So you will get 21. Now this will be 28 I,
Now this will be I
and plus 7 into minus 1.
and plus 7.
So let us simplify this. So this will be 14 plus 28i, yeah, after simplification. 21 minus 7, which is 14. So let us solve this. So this can be written as 1 minus I whole square and to the power of square. Okay, we can rewrite that. Now this will be whole square, which is 1 square. Okay, and this is plus I square and minus 2i whole square. Now I square is minus 1, so this one and this one gets cancelled. Okay, plus 1 and minus 1. Okay, So you'll have only minus 2i square, and which can be written as minus 2i into minus 2i. Yeah? Also, which is 4i square, or minus 1, minus 4. Yeah.
Yes, sir.
So let us find the multiplicative inverse of a given complex number. Z is equal to root 5 plus 3i. Okay. Now the conjugate of this would be root 5 minus 3i. Okay. The formula to find the multiplicative inverse, uh, Z inverse is equal to Z bar by mod Z square. Okay. So Z square is equal to, which is uh, root 5 whole square plus 3 square, right? So we get that as 14. 5 plus 9, which is 14. So the inverse will be root 5 minus 3i by 14, or root 5 by 14 minus 3 by 14 into I. So this is the multiplicative inverse of the complex number. So let us convert this in a polar form, right? So here we have been given z as 3. So let r cos theta be minus 3, okay, which is in the form of x plus iy, and r sin theta, which is 0. Okay, squaring and adding. So you get r square cos square theta plus r square sin square theta, which is minus root 3 whole square. Okay, so on further simplifying, r square is equal to 9, or r is equal to 3. Okay, so we got this. And now, since we got r as 3, so 3 cos theta is equal to minus 3. Okay, and this 3 sin theta is equal to 0, or sin theta, which is 0, right?
Yes, sir.
And this cos theta will be minus 1, or theta is pi. Okay, now we got the theta as pi now. So let us, therefore, we have minus 3, which is r cos theta plus I sin theta, or we can write this as it is 3 cos pi plus I 3 sin pi. Okay, or the polar form, which is 3 times cos pi plus I sin pi. Okay, or 3 e to the power of I pi. Okay, so which is the required polar form. Okay, okay.
Sir.
So let us try to solve this now. Okay, So z is equal to I, which is in the form of x plus iy. Okay. So let r cos theta, here it is 0, okay, and r sin theta, which is 1, okay. So squaring and adding, so you get r square, which is cos square theta plus sin square theta, which is 1. So on the right hand side, 0 square plus 1 square, which is 1. Okay, this implies that r is equal to 1. So we got r as 1. So cos theta, which is equal to 0, okay, and sin theta, which is equal to 1. Okay,
Yes, sir.
yeah. Now we got theta as pi by 2. Okay, because sin pi by 2 is 1 and cos pi by 2 is 0. So we got theta as pi. So now, therefore, I is equal to r cos theta plus I r sin theta, which is r we know, which is 1. So this will be cos pi by 2 plus I sin pi by 2. Okay, or we can write as e to the power of I pi by 2. Okay, which is the polar form. So let us find the modulus and the argument of the given complex number. Okay, so z as 1 plus 2i by 1 minus 3i. Okay, okay. Now you have to multiply and divide by the conjugate of 1 plus 1 minus 3i, which is 1 plus 3i by 1 plus 3i. Okay, okay. So after multiplying it, you get this as 1 plus 3i plus 2i plus 6i square, and in the denominator it is a square minus b square. Okay, so on further simplifying it, you get this as minus 1 by 2 plus 1 by 2i after simplifying every part of it. So which is in the form of x plus iy. Okay, now this will be r cos theta, which is, what is it, minus 1 by 2, r sin theta, which is 1 by 2,
Plus
right,
1.
plus 1 by 2, yes,
Yes, sir.
squaring and adding, so you get r square, okay, which is equal to minus 1 by 2 whole square plus 1 by 2 whole square, squaring and adding, okay, squaring
Yes, sir.
and adding. Okay, now this results to r square, as this is 1 by 4 and 1 by 4. So 1 by 4 plus 1 by 4, which gives half, or r will be 1 by root 2. We got r now. Okay, once we get r, okay, we will consider r which is greater than 0. So this will be 1 by root 2 cos theta, which is equal to minus 1 by 2 and 1 by root 2 sin theta, which is equal to 1 by 2. Okay, so we'll get cos theta, which is after simplifying you get minus 1 by root 2, minus 1 by root 2, and the sine theta, we'll get that as 1 by root 2. Okay. Okay, so now theta will be, now we got cos theta as minus 1 by root 2 and sin theta as root 2, 1 by root 2. So theta will be pi minus 3 by 4, okay, or which is equal to 3 pi by 4, where theta lies in the second quadrant. Okay, so now we got the argument as 3 pi by 4 and r, which is the modulus, which is 1 by root 2.